Okay, grade 12s, let's revise tree diagrams from grade 11. And in this example, I'm going to be focusing on independent events. And then in the practice example, I'm going to give you something on dependent events. Okay, all of this is in the grade 11 lessons on probability. This is just mere revision that you must know. They're going to test this in matric, so be aware of this. Okay, let's just read the definition of independent events quickly. Two events A and B are independent if this holds true. The probability of A and B is the probability of A multiplied by the probability of B. What it says is if you got something that happens, an event that happens, for example, it's like drawing a marble out of a bag. Okay, and then you put it back. Then the second event is taking another marble out the bag. What we know is that the probability of that A and B happening, so A happening and then B, is the probability of A times the probability of B. And in grade 11 we explored that in a lot of detail. Just hold on to that. Let's do an example to clarify what we mean. Okay, as I say, in grade 11 there's a lot of notes on this. Okay, so let's just revise this now. You're going to need it for matric. There are 6 green pencils and 5 blue pencils on a table. So there's 6 green pencils and there are 5 blue pencils on a table. Okay, Mbuyi removes, that's the first event. He removes a pencil from the table and then puts it back, replaces it. Then, the second event, he removes another pencil, but replaces it again. Now, we need to draw a tree diagram of these events. Okay, now have a look here. So, we've got 6 green and 5 blue. So, if you look at the first time he removes a pencil off the table, we could have got a green first, followed or a blue. We could have got a green or a blue. Now remember, there's a total of 11 pencils. There's 6 green and 5 blue. So what is the probability that the first time round he draws a green? It's 6 out of the 11. The blue is 5 out of 11. You see, there's 5 blue pencils. So the chance or probability of removing a green would have been 6 out of the 11 in total, and the probability of removing a blue would have been 5 out of 11. Okay, cool. That's the probability there. Now, okay, he puts the pencils back. Now, the second time round, well, if he chose a green the first time around, on the second time he could have chosen a green or a blue. Okay, had he chosen a blue the first time round, then he puts the pencil back, the blue pencil back. He then does it a second time and he could have got a green or a blue. Okay, now have a look at this. Do you notice something? If Mbuyi replaces the pencil, your sample space or your number of pencils still remains the same. There's still 11 pencils for the second event. In the first event, Mbuyi picks a pencil off the table. It could be green or blue. 6 out of 11 for green, 5 out of 11 for blue. That's the probabilities. But then he puts the pencil back. So when he does it a second time in the second event, there are still 11 pencils. And what is the chance of getting a green then? Is still 6 out of 11. For the blues, it would still be 5 out of 11. So if he picked a green the first time round, the probability of him then picking a blue would be 5 out of 11. Can you see that there? The green would be 6 out of 11. Now notice the second event is independent of the first event because it doesn't matter what happened in the first event. There wasn't anything that happened to the sample space. There were 6 green pencils, 5 blue pencils, 11 pencils in total. So Mbuyi picks a green or a blue, but he puts them back. So the second time around in the second event, there hasn't been a change to 11 pencils. There's still 11 pencils. So event B, the second event of removing a pencil from the table, is independent of what Mbuyi did in the first event, which was still removing a pencil. Okay, so it's 6 over 11. And notice that these fractions, 6 elevenths plus 5 elevenths, add up to 1. The sum of the probabilities is always 1. Now let's go here. if he picked a blue pencil the first time round and then he puts it back, there will still be 11 pencils to choose from in the second event. The green, there will still be 6 and there will still be 5 blue. You see that there? Now, once we've got our tree diagram, it's pretty easy to see. What we could say is that what would be the probability of getting a green followed by a green? Okay, now we're going to use this whole rule up here. This rule of PA and B is PA times PB. What it says is the probability of getting a green followed by a green would be 6/11 the first time round. The second time around is 6/11. So we multiply those. 6/11 multiplied by 6/11. Okay. What's the probability of getting a green followed by a blue? Okay, a green followed by a blue. So we go G to B. So that's 6/11 times 5/11. Okay, that's the probability of getting a green followed by a blue. There we go. Okay, what's the probability of getting a blue followed by a green? Okay, well, the blues are 5/11 and the greens are 6/11. So there we've got that one. And then what is the probability of getting 2 blues? A blue followed by a blue would be 5/11 multiplied by 5/11. You see, this is the rule of independent events. Okay, so let's now answer some questions. What did they say? What is the probability that both pencils removed are blue? Well, that'll be this one. So in B1, the probability of both pencils being removed would be 5/11 multiplied by 5/11, which is 25/1 to 1, as you can see there. Okay, now the next one, let's look at number 2. What is the probability that a green followed by a blue is removed? So it's a G, then a B. So what would that be? It would be G to B, 6/11 times 5/11. Okay, so that's 6/11 times 5/11, which of course is 30/1 to 1. Okay, now watch out for this one, number C. What is the probability that a green and a blue pencil is removed in any order? So we could have started the first time by a green, taking a green, followed by a blue, or we could have had a blue followed by green. So it's those two. We're going to add those two options. So we've got a G and a B. So in the third one would be a green times a blue, or we add to that a blue times a green. Do you see that there? Okay, so that gives you 30/11 plus 30/11, or 121 should I say rather, because we're multiplying that there. There we go. So that gives you 60/121, and that's the probability there. Okay, now guys, remember these are independent events. What happens in the first event does not affect the second, because you're replacing the pencils, so there's no effect to the sample space. Okay, and just remember that you multiply, when you've got your tree diagram, to get the probability of a green followed by a green, you multiply the probability 6/11 times 6/11. Now, with dependent events, you're not going to replace the pencil. So Mboyi will take off a pencil off the table, but not replace it, and there's a lot of mathematics that happens there, and I want you to practice this. You did it in grade 11, but here's your chance to revise this in grade 12.